Hello and welcome to Console Cowboys. So we are going to do another one of those rabbit hole deep dive videos continuing on where we left off last time. This time we are going to take what we did manually and we're going to automate it a little bit via somebody else's tool to disassemble everything. And we'll take a look at that disassembly, make sure it looks close to what we did manually. After that, we are going to write our own Python brute force tool that rips through this bytecode or any bytecode that we feed to it, looking for function signatures, giving us the names of those back, and then verifying them with online databases or local databases. So that way we can get an idea of maybe what this bytecode does. In case we were just handed this bytecode, we captured it, we didn't have any source code, we don't have any decompilers or disassemblers. What can we glean from this bytecode based on what we learned last time? So if that sounds fun to you, we're gonna get ripping on that. I'd like to thank everybody again who is liking, subscribing, and posting this out on social media. All the retweets are helping get some more views on there, which is fantastic. If you wanna follow me on Twitter, you can grab that in the description below, so let's get into it. So let's first disassemble the bytecode and make sure it looks like what we did manually. We can do that with a Python tool called PyVMasm, and it's Python, so of course it's just a quick pip install PyVMasm, and we should be good to go. Once you do that, you will get a command on the command line you can run, evmasm -d for disassembly, and you can just echo in your bytecode. So I'm going to copy this, and we're going to go back into our editor in an untitled editor thing. I'm just going to paste that there. We're going to replace this bytecode right here with our target contract. So let me copy all of this here. And I'll replace it there. And then it's the -d, but what we need to do is we need to pipe that out to a file, otherwise it's going to fill our window. So we're just going to pipe it in Linux like that to output.txt. I'm actually in Windows right now, so instead of doing that, I'm just gonna run a PowerShell command. I hate using PowerShell, but sometimes it's useful. And what we'll do is we'll pipe it out with a set content command. So let me do that now. If you're on Windows, you can just do it this way. If you're on Linux, just use that greater than sign. And that should create us an output.txt with all of our disassembly in it. All right, cool. So I'm gonna paste this in here. That's all of our disassembly, and we should see an output.txt once we are done. And that is created right here. So what do we have in here? Well, it looks pretty much like what we did manually, right? So push 1, 060, push 1, 040, and then we store that. And we're gonna store at that offset of 40, the value 60. And we're gonna do our call data size. It's gonna bring back the size of message.data. It's gonna check if it's 0, and then it's gonna push that B7. We were right, that 00 in front of the B7 didn't matter. And then we're gonna do a jump I. If it is not 0, we're gonna jump to that B7. And if we cruise down and look for B7, we could probably see where it's going here. Oh, there it was. B7 is gonna jump to destination, which is probably gonna be one of these pushes up here where it's going. So just wanted to check and make sure our disassembly was okay. We're not gonna cruise through all of this. I'm gonna guess this thing is quite long. Yeah, 2156 lines. In here, you're probably gonna see a lot of big signatures like this. You'll probably see some of these signatures that are our function signatures. So you could actually try to parse this output for signatures and then run those through this code and see if they pop up. Could be an exercise you could play around with. What we wanted to do is just make sure that what we did manually, you manually disassembled all of that right there, all on your own by looking up the opcode. So that's actually pretty cool. And hopefully it makes you understand, how these disassemblers work a little bit. So now what we're gonna do is do our own coding, and we are going to create a signature database. We are going to run code that brute forces all of this bytecode, looking for as many signatures as possible of functions that are in this bytecode and can be used on this smart contract. So let's do that now. So when we're doing research and development, we need to think about a few things. Number one, what is our hypothesis of what we're trying to do and what the results are going to be? And then what is our application going to do, or our tests that are going to actually give us our results? And what do we think those are going to be? So our hypothesis is that we can take this bytecode and we can rip through a list of known signatures and we can figure out what this bytecode is possibly doing if it's using signatures in the database. So that is what our hypothesis is. And then how are we going to achieve that? Well, I have a Python program here. I don't have anything in it yet other than two obvious variables. First off, we obviously need the bytecode that we're testing, and we need to have the same bytecode every single time for testing so our results are consistent. So we could pull this from the blockchain new every time, but what if something changed or something happened? We want to just paste it in here and use the same exact test bytecode every single time. So we're going to paste that in here. Next up, we need a database of signatures to rip through this bytecode looking for. Now, we can create our own, or we can find a database somewhere. We'll go through that in a minute. But what does our application need to do with these variables? Well, we need to loop through our signatures database. Then we need to check if the signature is found in the bytecode. And then we need to look up the signature online or locally and print out the functions. And then we need to make it look pretty if anybody else is going to use it, or so that we can key into the proper data of what we're looking for. So first off, let's think about this. Well, we need to check the signature is found in the bytecode, so we're probably going to need to import something like a regex library, so import RE. We also need to do lookups online, so a requests library is what we're going to use, and we'll go through how to use those and simple ways to do it. Not going to be very complicated. Our idea here is to use the simplest code possible and get things done, not complicate matters. So I will roll through with very simple examples of this to get this done. Then, next up, we need to look things up. Well, the database that we had before on that 4-byte online is great and all, but it brings back a lot of 502 errors, which then starts giving you error messages in your console when you're doing it. And also there's not enough signatures in it. So sometimes you get a lot of false positives or false negatives where you're throwing in something, it doesn't find it, or vice versa. So what I did was I looked online and I found another signatures database at etherface.io/hash. Now the good thing about this one is that it also has a lot of information. So when you look up something, you can also look up like all the contracts that use a function and then see how they're used to get an idea of where they might be used and how they might be used within the contract that you're checking. So that's pretty cool. And also the results. So if I grab one of our old name hashes here and I grab the 4-byte signature, and what we're going to do is pop this in here. Our most likely result on this page comes up to the top, which is nice for, viewability purposes. The other one put it to the bottom, and the less likely ones were on top. So that is something I've noticed about this database. It works much better. So that's a much better place to make our web requests for lookups. So that solves that problem. And if we look at the data that comes back, here's the name function. It's between a text and between this hash. So, we can do some simple parsing on that to grab those when we're doing the website. So that's pretty easy. And the next thing to think about is, well, okay, so we know where we're going to look up signatures. We can make it pretty easy enough. We know how to loop through the signatures database, but where do we get this database of signatures to actually loop through? Well, I first found one in a GitHub on that 4-byte, but it was much smaller than what was available here, and I had a lot of false positives, and I had to add my own signatures for a lot of the contracts I was looking at. And I was like, yeah, this is cool, it's a good starting point, but I'd have to do a lot of work. Well, this website is always looking through Etherscan, grabbing all the signatures. So what we can do is we can find a database associated with this and then have it local and either do all our lookups local or at least pull all those hashes and then run them and look them up online. I would suggest the previous one so that way you don't overrun this website. But to start, easily we'll just make these lookups online, then we'll modify it. But don't tax this server or they're going to shut it down or do rate limiting. So please tread cautiously and only do a few lookups this way. So when I was cruising around the internet, I originally found this, and it talked about Etherface and the signature database being bigger than 4byte, but similar, et cetera, et cetera. Scrape signatures 24/7, blah, blah, blah. And then I came down to this Sam ZCZ Sons database. So that was very interesting. If I click that, it's another place where I can look up stuff, but you can also import stuff, et cetera. And there's this nice little link up here. If I click this, I come down and I see, oh, okay, this is a Swagger doc for an open chain API that has a database export function. Now, if you click this, it's going to like freeze up on you because it's like a 100 megabyte download. So what you can do here is instead just do something here, say try it out. Click this and we'll hit execute, which will give us the URL we want. So we see this is this v1 lookup URL. So copy this and we will paste it up here. And then what we need to do is look below at what we want to do. So we want to do v1 export. So if you just change lookup to export, it will export a database locally for you, which is something that I already did. So once you get that, you're going to want to parse it and see what it's doing. So we're going to do that in a moment. Let me open up a Kali VM where I actually have that database. So I have it on my desktop here. It is called export.txt. That's what it's going to pull down for you. So it's in text format. But if you open up on Windows, it's going to have memory issues, etc. Let's just cat export.txt and take a look at what's there really quick, and then I'll just Control C. So what we have here is we have our signature, comma, and then a particular name, and you'll see a lot of results that just kind of repeat in here. So if I scroll up to the top, here's 000, and here's a whole bunch of ones under 000. So there's a lot of repeat. So if we're doing lookups online, we're gonna wanna do a sort with a unique to pull these out of here. If we're doing a local database, we probably want all of these in here. We just wanna format it differently. So let's first parse out all the signatures that we want, and then we'll do some online lookups and find the URL to do that. So let's do that first, and we can do that with simple Linux command line. I don't want to try to do it in Windows because that means I need to use like PowerShell or all kinds of other piping and grepping things that I don't even want to try to mess around with on Windows. So we're going to do it on Kali. And we're gonna go right back to a technique I learned in my pen testing with Backtrack, which is now the OSCP back in 2006 when I took that class. It was a very, very long time ago. Nobody even knew about it at that point. But what we're gonna do is simple cat export.txt, and then we'll use some cut -d commands, right? So what I can do here is I can say cut -d, and we're gonna cut at the X, and then we're gonna print out the next part. So we'll say -F2, and that should give us everything after the X, right? So we can verify that. Yep, so 0, 2, 9, etc. So we got 1, 2, 3, 4, 5, 6, 7, 8. So that's the correct length. And then what we'll do is another cut here. We'll pipe this through. And you can do this any way you want. This is just the simplest way to do it. And it's very useful. So -d. And then we'll just cut out based on the comma. And this time we need -F1 to grab the first value. And what that should do there is we now have all of these. So we got 1, 2, 3, 4, 5, 6, 7, 8. So those are all of our signatures. Now we want to output this to a file. So we'll say output.txt, and then that'll give us all of our signatures. But then remember we had a lot of repeats. So let's hop into that Linux terminal again here, and let's this time cat the output. And let's do a word count on this. And it looks like we have 2532815, but now let's sort it first. Sort -u for unique and pipe it through, and let's see the difference. So that's going to take a minute because it's actually doing a little bit of sorting. And when we come back, it looks like we save about about 600 or 700 repeating things. So let's take that output. Instead of going to word count, let's send this to our signatures db.text. And then what we will have here is we now have a signatures database that we can use in our testing so that we can brute force all of these values within our bytecode. So we didn't even have to do all the legwork. And I will also take all of this sorted out stuff and I'll put it on the GitHub, which I'll give you at the very end of all of this stuff because I want you typing out this code. But for right now, you can just do what I did online. So let's grab our signatures DB here, and I'm going to copy that, and we are going to dump that into my directory. So I'm going to open up a directory here on the side and just go into that directory where all of our code is. So let me see, where is this at? 1 second. And I'm going to paste this in here like this, and it should show up right here. So this is our signatures database now, and we can use this in our program to rip through this bytecode. So let's start doing a bit of coding. I'm actually going to cut this video off right here because it ended up about 30 or 40 minutes long, and I'm going to post the other video right after where we code out this whole tool based on what we've done so far. So if you've learned something, give it a like and subscribe, and check out the next video after this. It'll make it a little easier for the viewers.